Okay, gang, last video, last new information that you have to learn. This is going to be the chi-squared test for independence. Okay, so this says, is the association in the sample evidence of an association between the two variables in the entire, between these variables in the entire population? Or could the sample association easily arise just from the luck of random sampling? So we are looking to see if two things are related, if there is a correlation, if these two things are associated, if one affects the other. So your null is that there's no association. No association between the two categorical variables in the population of interest. And your alternate is that there is an association. Okay, but remember, this is the chi-squared test for independence. So you can also see your null and your alternate written like this. The two categorical variables are independent in the population of interest, or there's no association. And the H sub A is that the two categorical variables are not independent, which means there is an association. So you can write this, or you can see it two different ways. So there is no association, or they are independent, saying the same thing. There is an association, or they are not independent. So the two highlighted in yellow are saying the same thing, and the two highlighted in green are saying the same thing, just two different ways. But one of them kind of has the not in the H sub O, and the second one has the not in the H sub A. So just make sure that you're good with the fact that there's no association means that they are independent. And then if I do the green, if there is an association, that means they are not independent. Now, this is the chi-squared test for independence. So if you want to use the are independent and are not independent, because it just kind of goes with the title, that's totally fine. Just remember, multiple choice, if you see the words association, that's also independence. Your expected counts in your table are identical to chi-squared test for homogeneity. Your conditions, random, independent, LCC, expected counts must be at least 5, all exactly the same. Chi-squared, exactly the same. Find a compute on the calculator, but they want you to show a few steps of the calculator. We've done that before. P-value is exactly the same. Degrees of freedom for a two-way table is exactly the same. Conclusion, since the p-value is less than or greater than the level of significance for this test, we reject or fail to reject H sub O. There is or is not enough evidence to conclude that there is an association between blank and blank in the population of blank. So remember, your evidence statement is always about your H sub A. So there is or is not enough evidence to conclude that the two categorical variables are not independent if you go with the second set of H sub O and H sub A. So this can also be replaced with not independent. Because remember, your evidence statement is always about your H sub A. Okay? Angry people and heart disease. A study followed a random sample of a bunch of people with normal blood pressure for about 4 years. All of the individuals were free of heart disease at the beginning of the study. Each person took the Spielberger Trait Anger Scale test, which measures how prone a person is to sudden anger. Researchers also recorded whether each individual developed coronary heart disease. This includes people who have heart attacks and those who need medical treatment for heart disease. Here's a two-way table that summarizes the data. Does the data provide convincing evidence of an association between the anger level and heart disease in the population of interest? All right, mine's already filled in. I don't know for certain if yours is or not, so I'm going to assume that if yours is not, you can pause this and write it in at your pace. But because this is so similar to what we've done in the past, we're just going to kind of focus on the tweaks that you have to do. So you guys can see the green numbers in my table. And again, you're going to show where those green numbers come from. I don't in this work, but you're going to show column total times row total over total to get one or two of them. And then fill in all those green numbers. Because you see, is there evidence of an association? So I think the biggest thing here is to make sure that you know the difference between a chi-squared test for homogeneity and a chi-squared test for independence. Because I think goodness of fit is going to be really easy to pick out because the goodness of fit has a one-way table. So goodness of fit, you need to think M&Ms, you need to think NHL hockey players' birthdays, you need to think astrological signs. Those are all goodness of fit. But homogeneity and independence are both going to be in a two-way table. So obviously we're going to focus on independence today, but kind of keep in the back of your mind, how am I going to tell the difference between a homogeneity and an independent test? Okay, so does the data provide convincing evidence of an association between anger level and heart disease? I just want to know, are these two things related? So I'm going to use their wording. Since they talked about an association, that's what I'm going to use in my null and my alternate. So my null is that there is no association between anger level and heart disease in the population of people with normal blood pressure. And your H sub A is there is an association. Okay, the alternate for that, your null could be anger level and heart disease are independent. And your H sub A, anger level and heart disease are not independent in the population of people with normal blood pressure. So no association and are independent, same thing. Is an association and are not independent, same thing. Conditions, this, I think it says it was random. Yeah, study of random sample. Okay, and here's something that's super obvious, and this is honestly one of my go-tos for trying to figure out if it's homogeneity or independence. Only had one sample. I only have one sample. Now, a chi-squared test of homogeneity has two samples. Let's see, what was the one from homogeneity? It was two different college campuses, I think it was. So two completely separate samples. So when you did your independent, you had two of these, one for each sample. Well, for independence, it's only one sample. So I only have this one time. LCC, all expected counts greater than 5. See the table. There's your chi-squared. Show a few. Get your chi-squared. Find your p-value. Show your degrees of freedom. P-value is tiny. Since our p-value is less than level of significance for this test, we reject H sub O. There is enough evidence to conclude that there is an association between anger level and heart disease in the population of people with normal blood pressure. Our data is statistically significant. Same old, same old. Okay, both the chi-squared test for homogeneity and the chi-squared test for independence start with two-way table of observed counts. Then you need to find expected counts, check the conditions, same for both tests, calculate the test statistic, that's your chi-squared, degrees of freedom, and find the p-value, all the same way for both tests. The questions that these two tests answer are different. Okay? Homogeneity tests whether the distribution of a categorical variable is the same for each of several populations or treatments. There are two populations of interest, two sample groups, one variable or treatment. So homogeneity. Homo means same. So I think it makes sense that there are two populations. I'm trying to see if these two populations have the same distribution. Independence tests whether two categorical variables are associated in some population of interest. There is one population of interest, one sample group with more than one variable. So if I think about I think it was college campuses and Facebook use, I had two samples, one from the main campus and one from the satellite campuses, but I only had one variable, Facebook use. But for independence, I have one population and two treatments. So this one was cholesterol, heart disease and anger level. One population, one sample, two different variables. Scary movies and fear. All men and women equally like to suffer lingering fear from watching are men and women equally likely to suffer lingering fear from watching scary movies as children? Now, I don't know about you, but I watched some scary movies as a kid that I probably shouldn't have, and they scarred me for life. So, it says researchers asked a random sample of 117 college students to write narrative accounts of their exposure to scary movies before the age of 13. More than 1/4 of the students said that some of the fright symptoms are still present when they are awake. Do you run down the hallway when it's dark? Do you, if you have to take the trash can to the end of the driveway, do you freak out that something's in the woods? Do you check underneath the bed, or do you run and jump into the bed from very far away so the monsters underneath your bed don't grab your ankles? The following table breaks down these results by gender. Now, I didn't ask a sample of males and a sample of females. I asked a sample of 117 college students. I have two variables. I have gender and I have fright symptoms. Make sure you see that because when you start a problem like this, you have to decide between homogeneity and independence. If you pick the wrong one, you're doing an entire test that's wrong. Even if you do the test correctly, you made the decision at the very beginning for the wrong test. Now, you won't lose all points, but you'll lose the bulk of your points. Okay, so I've got a mini tab output for a chi-squared test, and I just want to make sure that we can read this test, read the mini tab, and know what kind of information it's giving us. So chi-squared test, male and female, expected counts are printed below observed counts. I'm just reading right here. Expected counts are printed below observed counts. Chi-squared contributions are printed below expected counts. So guys, I've got observed, I've got expected, and then I've got the chi-squared. So what's highlighted in blue is what would be in your L3, the individual chi-squared, chi-squared contributions. So again, this is my observed, there's my expected, and there are my chi-squared. Not something you have to memorize, but something you have to be able to read and figure out what's what. It gives me my total chi-squared number down here. It gives me my degrees of freedom, and it gives me my p-value. I have my total sample size. Okay, it says assuming that the conditions for performing inference are met. Okay, so we don't have to do our conditions. Explain which chi-squared test should be used in this setting. Okay, so number one, this should be a chi-squared test for independence. I have two categorical variables, and the subjects came from a single sample. My categorical variables are gender and fright symptoms, and I want to know if they are associated. Question said, are men and women equally likely to suffer lingering fear from watching scary movies? I want to know if these two variables are associated. State an appropriate pair of hypotheses for researchers to test in this setting. H sub O, there is no association. They are independent. H sub A, there is an association, or they are not independent. Interpret the p-value. All right, here it is. Here's your favorite. Interpret your p-value. Okay, here we go. If gender and fright symptoms really are independent, okay, so there's if my null is true. In the population of college student, there is a 0.045, that's my p-value, probability, okay, now here it is, of observing a chi-squared of 4.028, that's my chi-squared, or higher. Now, this p-value is going to have an or higher for every chi-squared test you do. Because remember, chi-squared tests are always right-tailed. So it will always be your p-value or higher. So interpreting this p-value is kind of easier than all the others. So if my H sub O is true, there is a, whatever your p-value is, probability of observing a chi-squared of, whatever your chi-squared is, or higher. What conclusion can you draw at the 1% level of significance? Since our p-value is greater than the level of significance for this test, we would fail to reject H sub O. There is not enough evidence to conclude that, whatever your H sub A is, there is an association between gender and fright symptoms among college students. Our data is not statistically significant. Okay. Two-way table. Two samples, one sample. One variable, two variables. Don't memorize it, understand it. Homogeneity means the same, so I need two samples to compare to see if they are the same. Independent is more talking about the two variables. Are the two variables independent? One sample. Okay, ladies and gentlemen, I hereby declare that you have learned everything that you need to learn for AP Statistics. Congratulations. You have a crap ton of information in your head. So let's get through this test, and then we will start the process of reviewing and dusting it off and bringing it all back to the front of your noggin and see if we can get you guys some college credit for this. All right, so nice job, well done, and congratulations, way to be done.